Morning to all. In today's session, we are all going to learn about the hypothesis testing and its related correlation testing. So let's begin with the introduction. What is all about the research hypothesis is. A research hypothesis is a guideline, is a framework which totally provides a stranger, a researcher, a learner, a stranger, a clear, a testable statements which always gives them a direction about what on which path your study will actually have to go and what type of study that you are actually dealing with. The main benefit of the research hypothesis is to select the appropriate research methods or the statistical methods or the techniques wherever is possible so that the data could be easily analyzed and what would be the results and you can see the interpretation that a particular researcher would get from the hypothesis. It makes more effective in achieving exact results. So basically, a research hypothesis is a declarative, a statement is an or assumptive statement which a particular researcher has to mention in his or her study to prove and which related to the research objectives and the title. So above all, the main idea that a particular learner or a researcher has selected for his or her research, it always makes the study more focused and whatever the declarative statements that has been chosen by them, it does the best all of them. So at the end, when the researcher makes any proposal and about his related to his own study and just prepare and develop then hypothesis statements and then test the statements by using of collecting the data, analyzing the data using the research methods and the statistical techniques, then accordingly they can confirm and reconsider or reject any theories which is based on the research hypothesis. So let's begin with the meaning of hypothesis. What is hypothesis is all about? It is a fundamental, you can say, an element, not in terms of data collection methods. It always termed as the qualitative and the quantitative research methods. Hypothesis should be precise. It should be a statement, a declarative statement or an assumption statement that can be testable, which always based on the assumptions which made up by the researcher, which shows a positive relationship between two or more variables. So basically, in simple sense, I could say hypothesis is developed either based on the existing theories, it is based on your observations, it is based on any of the previous research studies, and it always aims to provide a research direction to the researcher that how to investigate in the further processes or the steps. Hypothesis is always starts with the research questions that how the researcher is trying to answer their research questions which is related to his own studies. It also reveals an outcome, an effect, and provides a basic ground to how to construct the investigation by applying the statistical methods, by applying the methods of data collection in terms of surveys, questionnaires, or any observation or any other methods that a particular researcher is willing to apply for. It also explains what a researcher is stated trying to find out its own investigation related to the stated hypothesis in a particular study. So once the researcher expectations are clearly stated in his study, he will able to build up the research methodology about what the methods are to be chosen or to be selected, what would be the sampling design, what would be the data analysis plan, and what would be the exact research design and approaches to be selected in his study for the data collection or for his own research study. So that is the exact meaning of the hypothesis in detail. So let's begin with the following examples of the research hypothesis related to the marketing and economics. But before I come up, you need to understand the main types of variables, that is the independent variable and dependent variable. So independent variable, as the name stands alone, which do not influence by any other variables. So and such variables can be manipulated, can be controlled in an experiment to observe what would be the effects on the other variables. So that's called the independent variable. Dependent variable, as it is dependent on the other variables, which you can say which can be measured, which can be observed in an experiment to assess that what would be the impact on that independent variable. So there is a difference between the independent and dependent variable. That independent variable is always being measured, observed, and controlled in an experiment to look after or to observe the effects on it. But dependent variable is exactly, it can be measured, it can be observed in an experiment to assess what would be the impact on the independent variable. So this is a basic difference of the independent and dependent variable to understand the concept of the research hypothesis. So whenever a particular researcher is trying to prepare the hypothesis statement, always be remember that the two main variables, dependent variable and independent variables, are to be included. So let's look after the example of marketing, the hypothesis statement which a researcher has been made up for his study, that is the consumers exposed to advertisements with the emotional appeals will have a higher purchase intention. So automatically the consumers who always look after the advertisements and which always having an emotional appeals in such advertisements will definitely have a higher purchase intentions with those which always have any rational or a normal appeals in their advertisements. So what would, this is a hypothesis statement, and from the hypothesis statement you have to clearly mention what would be the independent variable and the dependent variable. So the independent variable is a type of advertisement appeal, because advertisement appeal is almost the type of advertisement appeal is almost an independent which stands alone, whether it could be any type of advertisement appeal as well. But the dependent variable is purchase intent, because purchase intent is dependent on the you can see type of advertisements which was exposed to the consumers. So automatically dependent variable is a purchase intention, and how much the purchase power could be increased or decreased by looking after the advertisement with the emotional appeals. So automatically you have to mention while making up the research statements in case of marketing discipline or area. When we talk about the another example which is related to economics, the hypothesis statement is increasing. So these statements are the declarative statements, and these statements are the assumptive statements which a particular researcher has to test in his study. So hypothesis is like that in case of economics is increasing. The minimum wage will decrease the employee turnover rate in the retail sector. So this is a statement, assumptive statement, which has been made up by the researcher, and the researcher has to identify what would be the independent variable and dependent variable. So the independent variable is a minimum wage increase. So automatically it stands alone. You're increasing the minimum wage is an independent variable. So automatically influence the dependent variables, that is the employee turnover rates. So this is the main case of the economics, that how to identify in the hypothesis statement what would be the independent variable and the dependent variable. Now we can come up to the next section, that is the importance of hypothesis in research. So these are the seven main importance. That is, it guides the research process, define the variables, what would be the variables, whether independent, dependent, extraneous variables, and facilitates the testability and the empirical investigation. It also focused on the objective based research. It promotes the critical thinking and the theoretical framework, that in other words we can call the conceptual framework, in terms which relates to the existing studies. It enables the structured and analysis and interpretation also, that what the researcher was planning to do the data analysis and interpretation, it will be a structured manner and drive a scientific process. So what would be the results? It would be tested scientifically, so that the results could give an impactful meaning to the readers. So this is an importance of hypothesis research. So let's have an overview one by one about these points related to the hypothesis in research. The first one is guides the research process. So hypothesis, which always gives a framework, a clear direction about to the researcher and how he should intend to begin a study and how it will make statements related to the to his study. We talk about the relationship between two or more variables, etc. So it should be precise to or you can say very specific or precise to a research title, a point, which always helps to formulate their research questions, and accordingly they will plan their methodology. So using the hypothesis, it always helps the researcher to test the process from the beginning to end of the study. Next, we talk about the define the variables. Now, when you're planning, when a researcher is formulating any hypothesis, he or she must specify the dependent and the independent variables. It also defines the objectives, that how much the variables could be measured, could be manipulated, whether the dependent variables will be measured and observed to exactly assess the impact of the independent variable as well. So according to the definition of the hypothesis, it is totally based on the assumption which showing up the relationship between the variables, two or more variables. So as statistics is always a field of research, so hypothesis is always an assumptive statement which will be testified using the statistical methods or the research methods. Next is the facilitates the testability and the empirical investigation. So a well-defined hypothesis, which is made up by the researcher, which always clearly indicate a relationship between two or more variables or the studied variables or the variables which are included in or his study. So automatically or accordingly, it provides a foundation, a rooted base for the designing the experiments and the observation, that what type of data collection methods will be used to fulfill these hypothesis statements. So automatically, in some cases, there are two main types of hypothesis: a null hypothesis and alternate hypothesis. So in case of null hypothesis, which shows no relationship between two and more variables, so automatically it could be tested to apply the statistical tools so that the particular researcher can either validate and reliable whether validate the formulated statements or not using the statistical tests. Next one is it enhances objectivity. The hypothesis is always helps to, you can say, the researcher to minimize any errors, any base errors when they are implementing or they are formulating any specific assumptions or predictions or hypotheses, because it always helps the researcher to main focus on the empirical data, the data which the researcher has been collected or using the secondary data. So once they're using any secondary data, accordingly they will predict the hypothesis statements rather than refer any subjective opinions or belief. Because after all, the hypothesis statements cannot be formulated which are based on your beliefs and opinions. So it should be based on the assumptions which are based on the empirical data which is available in our or using up from the outside sources, and accordingly it could be formulated. So it should be based on the research objectives, the objectives the researcher has been formulated in his or her study. So this objectivity is very crucial, because after all, it maintains the integrity of the scientific process, and it also ensures that the findings that we get are credible and reliable. Next one is it promotes the critical thinking and the theoretical frameworks. So while creating any reasonable or viable hypothesis, it is very important for the researcher to understand in depth about the problem and the field that he's willing to go for. So once they get a clear sense of the scope of the field of the research problems, and they just refer the existing studies and knowledges, so automatically knowledge, so there would be a way to go beyond what they have studied by referring the existing literature to get something original in their hypothesis statements once after the you can say go for evaluating it and identify the problems or questions which are actually remains unsolved. So the hypothesis statement should always refer a critical thinking and follows a theoretical framework and the magistries which are remain unsolved, or the concern or issues which are remains unsolved in the study. Next is it enables the structured analysis and interpretation. So the hypothesis is a tentative assumptions which always provides a particular framework for the data analysis, that a framework that how the data analysis process or the plan would goes on in a study by the researcher. It or hypothesis is always allow to determine what would be the statistical test or methods would be applied for proving the hypothesis statements in order to understand that how it will be interpreted accordingly. So if the results support the hypothesis, then there is a sufficient evidence to claim and infer that whatever the hypothesis or whatever the variables has been chosen, it's definitely is related to each other. And the last one is it drives the scientific process. So testing hypotheses it always allow the researcher to upgrade their knowledge, to enrich their knowledge beyond investigating a particular aspect or a concern or issue or any issue which are remain unsolved. So the data which is supporting the hypothesis, definitely the research will give the sufficient evidence to prove that hypothesis and conclude it accordingly, but it also may give a rise to new theories a development of the new theories, which serves as a route for a new research to the new learners, to the new readers as well. So if any loop significantly benefits the researchers who need to extend their knowledge, to need to extend their understanding of a particular aspect of the outer world, or the, you can see, the situations which goes beyond investigating what they have already investigated in his study. So that is called the drives a scientific research progress, which is one of the importance of hypothesis in research. Now we can come up to the next concept, which is an important concept, that is called the hypothesis testing. That how the hypothesis to be tested, what would be the types of hypothesis which could be used in testing such statements. So the hypothesis testing is a tool for making a statistical conclusions or inference about the population data. So automatically it's just show it is to be, the test is to be done once making up statistical conclusions or the results about the population data. So it is termed as an analysis tool which always tests the assumptions and determine that how the particular declarative statement is to be proven within the given standard of accuracy. So hypothesis testing is always provides a way that how to verify whether the results of the experiments are valid or not. So when we talk about the hypothesis, we always talk about the one of the hypotheses which is mostly used in testing it. That is called the null hypothesis and alternate hypothesis. These types of hypotheses are to be set up before performing any hypothesis testing. That means such statements is to be prepared, and once we have performed formulated this hypothesis, now there is a time to test the hypothesis through using of the statistical test. It could be the t-test, it could be the chi-square test, or it could be the correlation test. So this testing, which always helps to reach out the meaningful conclusion regarding the samples which has been obtained from the population data. So hypothesis testing can also be termed as a statistical tool which always used to identify what would be the outcome of the experiment, or whether the exact results we could get from testing the hypothesis or not. So this is something, a statement which a researcher is need to prove by or with the sufficient evidence. So it always involves in setting up a null hypothesis and alternate hypothesis. Null hypothesis, which always refers that there is no relationship between one or more variables or one or two variables. But alternate hypothesis is the opposite of the null hypothesis, which always refers that there is a relationship between two or more variables. So that is why these two hypotheses are mainly used to test the hypothesis or performing any hypothesis testing using the statistical tools. So there is an example, there are two hypotheses which are mutually exclusive. So this means if the null hypothesis is true, that means the alternate hypothesis is false, and vice versa. So that means there is an inverse relationship between the null and alternate hypothesis. If the null hypothesis is true, the other hypothesis will become false. So an example of hypothesis testing is always being set up to check on whether any new medicines work on a disease or not in a more effective manner or not. So this is a hypothesis statement which a particular researcher has to prove, and this statement we call an alternate hypothesis, where which states that to check on whether a new medicine works on a disease in a more effective manner or not. So this is an alternate hypothesis which considered as an example to prove, and a researcher has to testify using the statistical tools with an app with after collecting the data. So these are the two main types, null hypothesis and alternate hypothesis. So once the researchers prepare these hypotheses, then the testing process of hypothesis would goes on. So null hypothesis is a concise mathematical statement which always used to indicate or reveal that there is no difference between any of the two variables or the two possibilities. That means there is no difference whatever the variables has been chosen by the researcher or in or between the population data. So this hypothesis is always assumes that whatever the outcomes of an experiment, of an observation, which totally based on a chances alone. That means it's totally based, it's a probability whether it could be yes or whether it could be no. But null hypothesis always goes on no. So it denoted by HO, which stands null hypothesis, and that is a symbol of null hypothesis. So the hypothesis testing is always being used to conclude if the null hypothesis is rejected or not. Let's take an example to understand the null hypothesis. There is a no significant difference in test scores between the students who study with the music and the students who study in silence. So this is the null hypothesis example. So if you are making any null hypothesis, you have to mention any no or not word, that there is no statistically significance relevancy between the test scores of students with music and with silence. So this is also another words you can prepare the null hypothesis. Now we can talk about the alternate hypothesis. When we talk about the alternate hypothesis, which is an opposite version of the null hypothesis. So, or in other words, we can talk as an alternate to the null hypothesis. It always means used to show up that the observations or whatever the observation of the experiments has been done are showing up some real effects, whether it could be the effects on the dependent variables or the independent variables or the other dependent variables as well. So if one variable influences the other variable or having some differences between the two variables, it becomes the alternate hypothesis. It also indicates that there is a statistical significance between the two possible variables or between the two possible outcomes, and it is denoted by H1. That means it is a symbol of alternate hypothesis, that is H1 or HA. So for the let's taking up the same example, or for the above mentioned example, which shows that there is a significant difference. As null hypothesis, there is no significant difference. But when we talk about the alternate, there is a significant difference in the test scores between the students who study with the music and the students who study in silence, and that's become and the alternate hypothesis, and this statement will reveal the alternate hypothesis or research hypothesis. Now we can come up to the more important concept. There are two main concepts, that is the population parameter and the critical reason before we proceed mathematical numerical questions. So we can talk about the population parameter. A population parameter has always been a fixed. It is refers to an unknown value which always reveals and some of the characteristics of the entire population. That means it is a statistical values which always reveals or describe that this value it comes from the population. It could be an age, it could be an income, it could be anything, it could be a knowledge, it could be a satisfaction, etc. And the examples of such statistical values, which is unknown value, we don't know, it could become the value could come, it could be in any numbers. And the examples including the population mean, standard deviation, median, mode, any proportion, any ratios which come up a value which is called a population parameter. Population, the concept of the population parameter in hypothesis testing are used to formulate the null and alternate hypothesis. And this concept will always guide the researcher that how they will design the study and select the one of the most important tool of the research methodology, and that would be the sampling methods. That what sampling methods could be used after preparing the hypothesis. It could be null or alternate or both. Now the next concept is the critical region. So if you look up the critical region, there is a critical values which has been decided, and once it will cross the values, we reject or we do not reject in the yellow portion. So if any of the values comes in the yellow portion, we do not reject the null hypothesis, and if any values which is nearest to the x-axis, we reject the null hypothesis, and that area will becomes the critical region. So when we talk about the hypothesis testing, a critical region is the set of values of the test statistic. We can talk about, when we talk about the test statistic, we always talk about the statistical tests. So critical region is a set of values of the any of the statistical test, whether t-test, chi-square test, which always been observed that leads to rejection of the null hypothesis. So if any of the values which is nearest or you can say to the x-axis, it will reject the null hypothesis, and if it is not nearest, we do not reject the null hypothesis. So the critical reason, in other words, called the rejection area. So if you look up the blue area, it is called a rejection area, or in other words, we can call the critical region. So if you look up the yellow portion where the values which are more than and comes under the yellow portion, we do not reject the null hypothesis. So in other words, we could say it is a defined by a critical value, which is a boundary between the critical region and the region where the null hypothesis is not rejected. So it's all about the boundary lines where the critical reason is where it shows a critical reason where the null hypothesis could not be rejected, and just having the differences between the boundary lines which shows in the yellow line, which shows that the null hypothesis will not be rejected. So this is the exact meaning of the critical region. Now we can come up to the next concept, that is hypothesis testing p-value. When any of the test applies after collecting the data, so automatically every study, every research study show up the p-value. What is that p-value? That's called a probability value. So using the any of the statistics test or the statistical tests. In hypothesis testing, the p-value is used. What the p-value shows actually? The p-value is used to indicate whatever the results obtained after the conducting a test, either it would be t-test, either it would be the z-test, either it would be the Carl-Pearson test, the correlation test, or either it would be the chi-square test. When such tests are applied to get to know whether the results are statistically significant or not, using up the concept of p-value. So p-value indicates that whether the results are statistically significant or not. And in hypothesis testing, and that's for in hypothesis testing, that's called the p-value, which stands for probability value. That means it also indicates the probability of making an error, either rejecting or not rejecting the null hypothesis. So probability is always comes either yes or no, but p-value is always indicates whether reject the null hypothesis or not to reject the null hypothesis. So such p-value which always comes in a number between 0 to 1. It could be 0.001, it could be 0.000. So such values is always comes under the p-value, or it could be 0.00. So such results which always comes in your research study, which indicates that whether to reject or not to reject the null hypothesis. So p-value is always being compared. So whatever the p-value comes in your results, it always compared with the significance level or alpha level. The significance level which could be, or alpha level which could be either 1% or 5%. For example, if the p-value comes 0.00 and the alpha level is 0.05. If the p-value is less than the alpha value or the significance value, that means we reject the null hypothesis. If we reject the null hypothesis, that means there is a statistical significance or differences between the possible outcomes or the stated variables. So this is how the hypothesis testing would be done using the concept of p-value. So once we calculate the p-value, the second step is to compare the p-value with the significance or the alpha level, and it is being chosen that alpha level should be considered or should be usually chosen between 1 to 5%. It could be 1%, it could be 2%, it could be 3%, it could be 5% as well. So if I've chosen 5%, so 0.05 and 0.00, that means the p-value is less than the alpha level. That means it's we reject the null hypothesis. If the p-value is more than the alpha value, we accept the null hypothesis. So this is how the results is to be concluded in your studies. Next one is hypothesis testing critical reason. So whatever the hypothesis has been stated by the researcher, now whatever the values has come up, you have to check on that values whether it is nearest, the value is nearest to the x-axis or it comes on the yellow portion, and accordingly you will accept or reject the null hypothesis. So the value that separates the critical region from the non-critical region, that would be the critical value. So the significance level is denoted as alpha level, which always measure the strength of the evidence, because alpha value and significance value, when we compare the probability value, p value, to get the you can see the evidence to prove our hypothesis statements, whether it would be statistical significant or whether it would not be statistical significant, and that could be done through the using the concept of the critical region which has been explained in the previous slide through the diagram. So the significance level always denoted as an alpha level, or both are the same concepts. So it is a measure would measure the strength of the evidence that a particular researcher would get in his study, and which stated, and it shows in your samples as well, whether to reject or accept the null hypothesis. And before making any conclusion about the rejecting or accepting the null hypothesis, it is very important to compare the values, and accordingly you can say came out with the outful impactful results for your studies. Now we can come up to the next concept in hypothesis testing, that is type 1 and type 2 errors. In statistics, there are two types of errors which always exist in our hypothesis testing in research. Type 1 error is a false positive conclusion, and type 2 error is a false negative conclusion. While making any statistical decision, it always involves uncertainties, which always shows up unlikely chances of the possibilities, where the risks are always involved in that errors, and that are actually unavoidable in hypothesis testing. So the probability which the probabilities or the possibilities or uncertainties of making type 1 error and type 2 error which always exist, and how type 1 error is a significance level or alpha level, and type 2 error which having a significance level or alpha level, that is beta. So these risks has always been minimized. Such errors can be minimized if a researcher is having a careful examination, a careful planning in his own research design. So this is an exact table, the errors types while making up a correct decision. So if let's suppose if null hypothesis is true or the null hypothesis is rejected, and a researcher has not rejected the null hypothesis, that would be the correct decision. If the null hypothesis is false, it's not true, and if the null hypothesis false is not true and the researcher has rejected that null hypothesis, that means researcher has taken the correct decision. That means it is a true positive. But type 2 and first error. So let's talk about second error. If the null hypothesis is false, or in other words, I could say if the null hypothesis is not true, and you can say the researcher has not rejected the null hypothesis, that means it's called the type 2 error, which stands beta, and it's false negative. I repeat once again, if the null hypothesis is false, and or in other words, if the null hypothesis is not true, that means, and the researcher has not rejected, that means it stands type 2 error. If the null hypothesis is wrong, is false, and knowing this fact that the researcher is not rejecting the hypothesis or null hypothesis, it stands type 2 error. When we talk about the type 1 error, if the null hypothesis is true, and when they, after knowing that the null hypothesis is true and the researcher is rejecting the hypothesis, null hypothesis, it stands type 2 error, that's called the false positive. And the probability refers to alpha. So when there is a correct decisions, when the null hypothesis is true, and researcher is not rejecting that null hypothesis, that's a correct decision, then the probability could be reduced by differences of 1 minus alpha value. But when the null hypothesis falls and the researcher has rejected the null hypothesis, that is called a correct decision. And in that case, the probability value will be calculated like 1 minus beta value. So this is how the type 1 and type 2 errors could be explained, and in these type of errors how the correct decision is to be taken, is to be considered, and through using this chart while calculating the probabilities values. Now, this is an example. Let's consider a null hypothesis. A man is not guilty of a crime. So in this case, type 1 error, that is a false positive. So he's condemned to crime, has done a crime, but he's not guilty or committed the crime. That means it is a false positive. Type second error, he's condemned not guilty when the court actually does commit the crime by letting the guilty or go free. That is the false negative. So these are the errors that you can easily identify while creating the null hypothesis, and it could be minimized and by using of the correct decisions with these errors. How to develop a research hypothesis. So the first one is identify the research problem and questions. So the researcher has to investigate the research problem using of the existing literature, observation, existing theories, practical issues, etc. Next one is it review the existing literature. Now there is a time to come to review the existing studies so that they can know about the topic, they can identify the theories which could be used in the new researches, and what will be the major gap in the knowledges or in the research that always helps the researcher to inform the development of the hypothesis. Next one is specify the variables, whether the dependent variables or independent variables or the extraneous variables that could be involved in your study. Dependent and independent variable, the concepts I already explained. So the any of the variable that you can manipulate in your study, that is independent, dependent variable, whatever the outcome and response you are measuring, it's always whether to have any influence on the independent variable or not, that becomes dependent variable. Then the next step is formulate the hypothesis. So once you identify the variables, you need to formulate a specific hypothesis based on your research problem, research literature review, and identified variables. So it always shows a relationship between the dependent and independent variable. So the two main hypotheses which we have in an example, simple hypothesis, the increased exposure to sunlight leads to a higher level of vitamin D in humans. So this is a declarative statement that you have to prove it by having a sufficient evidence after collecting the data from the respondents or the participants. Next one is alternate hypothesis. So automatically, once you formulate your hypothesis, it is very important to understand in depth about the relationship between your variables, and this will always helps to ensure that your hypothesis is well grounded and comprehensive in a organized or a structured manner. Ensure then once you conduct the hypothesis, now ensure the testability. You can start testing your hypothesis using the measurable, you can say research methods or the statistical techniques. Next, once you testify, you can start writing down your hypothesis, your concise statement, what would be the results. It should be very specific, precise and specific. and automatically it address your research objectives and or research questions. Once you have written down, you have refined your results after testifying your hypothesis statements. Now the next step is feedback. You need to take up a feedback about your results of the hypothesis. So before finalizing your hypothesis, you just take a feedback from your colleagues, your mentors, your peers in your field. And this will help you to identify the potential weaknesses or any of the issues in your hypothesis and you need suggestions. And definitely you can apply that suggestions and improvise your hypothesis statements. Finalize your statements, hypothesis. Once you have refined your hypothesis based on the feedback and consideration, then it always finalize it as a guiding statement for your research study. Characteristics of the good research hypothesis: it should be clear, it should be very specific. It should testify using the statistical tools which are based on experiments, observations, statistical methods, data collection methods, etc. Its verification is always a possibility to prove the hypotheses which are false. So it is very important when any of the hypothesis is false, you can easily take a scientific inquiry, a scientific investigation, revise your objectives, and re-revise based on your evidence. Next one, it should be grounded in theory. It's a root, the root of the good hypothesis should be based on the existing theories or literature. So it is normally you can say considered once the hypothesis to be prepared using up the existing studies and theories. So it is a base that how a researcher could understand the topic and build up a previous researches, you can say findings or one of the research established principles as well. And the next one is rationally. It always give a logical reasoning or explanation that what would be the expected outcomes of your study. So it's totally derived from a literature review of whatever the preliminary objectives that has been set up by the objective and totally based on your preliminary observations as well. So what the observations that you do which is related to your study, that could be the possible outcomes of your studies as well. Empirical relevance, it's always be there, so that it always relevant to the research questions and it relate to your field of study and of course contribute the existing study, and it's something new to show up wants to investigate while showing up a differences or the relationship between the variables. Next one is concise. While the hypothesis should be very clear and specific, it should be very concise and up to a point. It's a statement which is having a few sentences which summarizes about the relationship that you're showing up between one or two variables. Next is variables. You have to identify the variables which are involved and specify that how they are related to each other, whether it could be dependent or independent variable. Next one is observable and the measurable. So the variables in the hypothesis should be observable and the measurable, which always allow for the data collection and using such data which is being collected for the analysis purpose statistically. Next one is revisable. A hypothesis is not actually the conclusion of the study. It is a tentative assumption or prediction which always guides the research process and it is open to revise and based on your research findings. So this is a next concept is correlation coefficient. So correlation coefficient is a number which always measures that how closely the two variables, whether dependent or independent variable, are interrelated. And it could be related through the ranges which comes under the coefficient of correlation from -1 to 1, which 0 indicates no relationship. So -1 is a perfect negative correlation, 0 stands for no correlation, and 1 stands for perfect positive correlation. So let's proceed a more diagrammatic presentation. This is how the correlation coefficient will be shown through the diagrams through your in your research studies through the diagrammatic and the pictorial representation. A positive correlation which always stands a positive relationship between two or more variables. Negative, it's downward sloping curve which always shows a negative correlation. So if you look up the dots over here, the dots is always showing up the upward sloping, and same in the negative dots showing a negative sloping. When we talk about no correlation, it stands a horizontal line where the points is goes on the horizontal side only, and that stands no correlation. These are the mathematical formulas of Karl-Pearson correlation coefficient, which stand R as correlation. Sigma x minus x bar, and then y bar is a mean of x variable, is a mean of y variable, y minus y bar by under root sigma x minus x bar whole square under root y minus y bar whole square. There is an alternate formula which is called a covariance formula. Covariance formula in respect of x and y variable, which equal to sigma xy and by n. So this is an example that how you calculate the Karl-Pearson coefficient of correlation using up the following data, where the data of two variables x and y, that is 1 to 5 and 10 to 50. But this now you need to calculate the value of Karl-Pearson coefficient using this data. So this is a table that you have. This has been shown up. X data and Y data is already given in the question, and you need to calculate the Karl-Pearson coefficient. So you need the formula says is sigma xy by n. So there is an alternate formula which is very easy to calculate the coefficient of correlation, and the formula of the covariance, alternate formula by covariance, that is sigma xy by n. So x square xy x and y, that is already given. So you need, the next step is you need to calculate the x square and y square. So if you look up the x square, 1 is already 1, 2, it's 4, 3, 3 is 9, 4, 4 is 16, and 5, 5 is 25. Same the case, we apply the same expect in case of y square. If you do the n square, it becomes 100, same for 20, 400, 30, 900, and so on. So once you multiply x, y, that is 1 into 10, 10, 2 into 20, 40, 3 into 30, 90, 4 into 40, 160, 5 into 50, 250. Now these are the values that we have calculated. Now we just total it of these two, if of these three section values, and then using up the formula, and then we estimate the Karl-Pearson coefficient. So just have a look. So this is how the Karl-Pearson coefficient has been estimated. That is x is 15, as we have total it. The total of x is 15. The total of y is 150, total of x square is 55, total of y square is 5500, and the total of xy is 550. If you're using up the formula of Karl-Pearson coefficient, that is sigma xy by n, so this xy is 550 and n is 15. So automatically you will get the value is 36.67. So this is how we can calculate the Karl-Pearson coefficient. Now, these are the ranges of correlation coefficient. If you look up the ranges, if any of the R value which comes under this 0.80 to 1, it is a very strong positive correlation. 0.60 to 0.79, it's a fairly strong positive. 0.40 to 0.59, it's a moderate positive, and 0.20 to 0.39, it's a weak positive, and so on. And -1 to -0.80 is very strong negative, -0.79, 0.60 is a fairly strong negative, and so on. -0.919 to -0.01 is a very weak negative. So these are the out of the level of correlation, these are the six main level of correlation which has been shown in the diagram. A strong positive correlation, it is a strong positively upward sloping from the origin. Weak positive correlation, and if any of the value which begins or any of the correlation between the two variables begin from the y-axis, it is a weak positive correlation. Strong negative correlation, it's downward sloping from y-axis to x-axis. Now, weak negative correlations automatically is beyond. You can see the values which comes under negative. Moderate negative correlation, which also comes under negative, which is a downward sloping from negative to negative, and the no correlation, there is no relations between any of the variables, as there is no line could be drawn over here. Testing for significance of the correlation. So once you're testing your significance, it is very important to apply the t-test, which call a test using the t-statistic to assess whether correlation coefficient is significantly different from zero or not. And before testing any hypothesis or before applying any t-test or t-statistic, you need to conduct the hypothesis, which is called the null hypothesis and alternate hypothesis, and accordingly you can apply the formula of t-test, and then accordingly you can easily justify whether whether the hypothesis should be accepted or rejected. That's it for today. Thank you so much for listening this lecture. I will come up to more and more important topics or relevant topics for this particular you can say course. So thank you so much, and namaste to all.